We're starting a new unit on rotating objects. Here's the concept map that I'll be using to teach you guys these the concepts of rotational motion. Pause the video and make sure that you get down this concept map. We are going to stick with, for the first series of lectures, angular displacement, angular velocity, angular acceleration, and rotational kinematics. So we're just trying to describe how things rotate. Let me take you on over to the next board because you paused it and you copied everything down in your notebook. This is our first... Oh, I dropped you. This is our first spin into rotation. So far, we have assumed that the objects that we look at don't rotate. So when objects go down a slope or an incline, we say, well, they are just fixed bodies. There's no rotation of them. Now we're going to look at what actually happens to the object when it's free to swing or spin. Some examples. Well, instead of taking this block, maybe I have a ball and I let it go down the ramp. So not only is there a translational motion as it moves down, but it's also rotating, as you can clearly see. Maybe I hop into this swivel chair and I do some swivels about the center of the chair. Tires down the road are rotating as they move forward. Turbines, pulleys, and planetary motion. We need to cover a few definitions before we go any further. The first I'll say is the axis of rotation is the line about which the object is rotating. So if I observe this thing rotating like this, I could easily imagine that there's some line, some axis of rotation about which the object is rotating. That's not the only line of rotation for this sphere. Maybe it's rotating in a different way. Maybe it looks something like this, and it's rotating like that. Question for you guys is, does the axis of rotation have to line up with some point on the object? No, it does not have to. Maybe I have my axis of rotation here in space, and my object is going around it like that. That's also rotating motion. So the axis of rotation is whatever line the object is rotating about. We're also going to assume rigid bodies. So everything that rotates keeps its shape, like this orange ball keeps its shape. And unlike pizza dough or Play-Doh, you can imagine that if I spin this Play-Doh fast enough that eventually this thing will start to deform if I toss it up into the air or put it into a system where it's spinning with several thousand RPMs. So we're going to assume that everything that is rotating keeps its shape. That's all for now. Stay tuned for more.